Okay, so I'll share my whiteboard. Can you see the whiteboard, Amir?
Yes, ma'am.
Okay, perfect. So this is the second lecture. We are still on chapter 1. We're talking about numbers. So let's continue with it. आज का जो topic content, it is not related to yesterday's class. So let's get started. Okay, so we have to discuss a very basic but important topic, that is prime factorization. Okay, so you know what a prime number is? We discussed that yesterday. Any number which is
Yes, ma'am.
divisible by 1 and itself, and 1 is not a prime number, right?
Yes, ma'am.
Okay, right. So if I talk about some basic numbers, let's say I say 12. Whenever you have been asked to prime factorize a number, let's say 12. If I want you to do the prime factorization of a number, let's say 12, you need to write 12 as a product of prime factors, right? Okay, let's talk about 12. 4 into 3 is 12, right? 4 into 3 is 12,
Yes, ma'am.
and 6 into 2 is also 12, right? Okay, so 4 into 3 is 12. If
Yes,
I
ma'am.
break down 4 into prime factors, can I write 2 into 2? And this 3 would come as it
Yes,
is.
ma'am.
So 2, 2, and 3. These three numbers are prime factors, and when I'm multiplying these three numbers, I am getting 12. So the prime factorization of 12 is 2 square into 3. Why 2 square? Because 2 and 2, they are same. When bases are same, I can add the powers, okay? This 2 has 1
Yes,
in
ma'am.
its power, and this 2 has 1 in its power. So I can just add this 1 and 1 to get 2. Okay, now what if we use 6 into 2? Let's do it this way. Now I have 6 into 2. 2 is already a prime number. I need to break down 6. I need to write 6 as a product of prime numbers. So those numbers are 3 into 2,
3
right?
square. Yes, ma'am. 3 square into 2. The prime
Not 3,
factors of.
not 3 square. 3 into 2 into 2.
Oh, yes.
Yes, right?
Yes.
This again is giving me 3
So
into
it
2.
would be 3 into 2 square.
Very good, excellent. So far we know whenever we have been asked to prime factorize a number, we just have to write the number as a product of prime factors, okay? Prime factors. These numbers are prime
Yes.
numbers, so be very careful with this. Okay, so 12 was an easy example. What if we talk about another example? Let's say we talk about 36. When we talk about 36, again, we need to think of 36 as 9 into 4, or maybe 12 into
Yes.
3, right? Because
6 into.
initially we cannot
Yes,
think
ma'am.
of prime factors directly. We can just think of such numbers. So I can write down 9 as 3 into 3 and 4 as 2 into 2, right, Amir?
2 into 2. 3 square into 2.
3 square into
2 square. 3 into square into 2 square.
3 square into 2 square, right?
2 square.
And if
Yes,
I do
ma'am.
it for this number, so 12 can be written as
12.
3.
6 into 2.
Yeah, very good. 6 into 2 and 3 into 4 as well.
3 into 4.
This 3 is coming here. So 3 and 4 can be written as 2
3
into 2
square 4.
into 3. So this again is giving me 3 square into 2 square.
3
Obviously,
square
in
into
exam,
2 square.
you will just be using
Yes,
one,
ma'am.
either this or this. Okay, I'm just telling you for your reference. So obviously, this method is not a
Oh,
very advisable method. Okay, I was just trying to give you an idea about prime factorization. So far, you just know what prime factorization is. If I want you to write down the prime factorization of 36, you will write 36 as a product of prime numbers. Okay, so this is what prime factorization is. All
yes.
right, so I think it's clear. Now I'll stop sharing the screen and I'll share another screen where we will talk about some divisibility rules. Okay, so I'll share the screen.
Like which number is divisible by which table?
Yes, yes, very good. Can you see the screen?
Yes, ma'am.
And do you see my cursor as well? Like it's on
No,
2.
ma'am.
No? Okay, that's okay. Let's talk about 2 first, okay? So this table is basically is a
Yes,
table of divisibility rules, okay? If you have 2,
yes, ma'am.
like you have a number and you need to know if that number is divisible by 2 or not. Let's say you have 40. Let's say you have 53. Now, obviously, you cannot think. You must have some rules in your mind by which you can know quickly that if that number would be divisible by 2 or not. Okay. And by divisible, I mean that when you divide that number, you get zero remainder. Is that clear?
Yes, ma'am.
Okay.
Like by 2 is if the number is even, so we like 0 is also even and
Yes.
2 is also even. So
Yes.
if
Very
a
good.
number is even, so it is divisible by 2.
Yeah, but look at excellent. Okay, so the question, so the rule is if the last digit is even or zero. Let's say the number is 856. Would it be divisible by, can we divide 2 by 856?
Yes, ma'am.
Very good. What about
Yes,
440?
because 6 is even. Yes, ma'am.
Very good. Okay, because 0 is at the end. Okay. So 2 is easy and we have been doing such questions as well. Let's talk about 3. If the sum of the digits is divisible by 3. Okay. Now, this basically means that if you have 81 and you need to think if 3 is,
Yes, ma'am. It is divisible. Divisible.
why?
Like, when we will add 8 and 1, it would be 9. So 9 is in the table
Very,
of 3.
very good. Excellent. Okay. And then we have 4. If the last two digits are divisible by 4, let's say I have 416. What if I have
Yes, ma'am.
416?
As 16 is 416, like 16 is in the table of 4.
Yes,
4 square is
excellent.
16.
Excellent. Okay, very well done. Okay, and then for 5 we have if the last digit is 0 or 5. So what if we
0 or
have
5.
525
Yes, ma'am.
and 582?
No, ma'am.
Very well done. Okay. Now for 6, the rule is if the number is divisible by both
Same as
2
the 3.
and 3.
Oh, yes,
Yes. If the number is divisible by both 2 and 3. So
2
let's
or
talk
3.
about 12. Now 12 is divisible by 3 and
6.
12 is also
It
divisible
2.
by 2. So it would be divisible by 6, right?
Yes, ma'am.
Okay. This means that since the number should be divisible by 2, so it should be ending with an even number or 0, and the sum should be divisible by 3. Why? Because for 3 we have if the sum of the digits is divisible by 3, and for 2 we have last digit should be even or 0. So is this thing clear?
Yes, ma'am. So in the 6, like it is compulsory that it should be both divisible.
For 6?
Yes, ma'am.
Yes, yes, for 6 it is necessary, okay? All right. Okay, I'll give you okay, wait. Okay. Just give me a second. We can do this on whiteboard as well, just so you are able to understand in a much better way, okay? I'll do that on whiteboard. So you are clear till 2, 3, 4, 5, but 6, 8, and 9 we can discuss on whiteboard. And I think Sareen is here as well. So let's go to whiteboard again and talk about things over there. Okay. So Saneem, are you there?
Yes.
Okay, I've shared the screen. You have not missed much. So I'll give you a quick recap and then we can continue. Okay. So far, we have just
Okay.
discussed prime factorization of a number, let's say 12, let's say 36. If we have 12 and you have been asked to write down the prime factorization of 12, how are you going to do that? You will write down 12 as a product of prime numbers. Okay, now 2, 2 and 3, all these are prime numbers. But when you multiply these three prime numbers, you get 12. So this is what prime factorization is. Prime factorization, okay? These numbers must be prime numbers. So you need to multiply some numbers to get this number whose prime factorization you are finding. And once you multiply these three numbers, you should get this number. Okay? Let's do an example together. Let's say I'm talking about 18 and you have been asked to find the prime factorization of 18. Okay. So how will you do that? You can write 18 equals 6 into 3. Can you write it this way?
Yes, ma'am.
Okay, now you're able to see the screen.
Yes.
Okay, Saeem, are you there as well?
Yes.
Okay. Right. So I was telling you that so far we have just discussed prime factorization. Okay. When we talk about prime factorization, you just have to write this number, this number, this number, or whatever number you have been asked to prime factorize as a product of prime numbers. Okay. Let's say we were interested in finding out the prime factors of 12. So these are the prime factors. I'll just rub it just so you are able to see it again. Okay. These are the prime factors 2, 2, and 3. We know that 2, 2, and 3 are prime numbers. And when I multiply these three prime numbers, I will get 12. Okay. If I talk about this 36, I need to write down this 36 as a product of prime numbers. Okay. This is what prime factorization is. So I know that 9 into 4 is 36, right? So I can write it down this way 3 into 3 into 2 into 2, right, Sunny? And then 3 into 3 is 3 square, 2 into 2 is 2 square. Is this thing clear?
Yes, it's clear.
Oh, all right. Okay. So let's do an example together. Let's say we are interested in finding out the prime factors of 18. So how are we going to do that? Okay. First of all, you need to write down that let's say 6 into 3 is 18, or maybe 9 into 2 is also 18, right? Now 3 is already a prime number, but 6 is not a prime number. Now you need to further break down 6 just so it is written as a product of prime numbers. You can say 2 into 3, and this 3 is going to come here as it is. So this would be 2 into 3 square. Similarly, if you follow this multiplication, 9 is not a prime number, 2 is. But you need to write down 9 as the product of prime factors. So that would be 3 into
3
3
into 3.
into 2. So this would be 3 square into 2. Yes, what are you saying?
बस मैम मैं यही कह रहे थे कुछ.
Acha, theek hai. Okay. So is this clear?
Yes, it's
Yes.
clear.
Okay, very good. So I'll just clear this and we'll talk about the divisibility rules. Okay, Saneem, are you familiar with some of the divisibility rules?
Oh, yes.
Okay, can you share some of the rules which you know?
A number which is divisible by 5 ends with 0 or 5. A
Excellent.
number divisible
Very well
by
done.
10 ends with a 0.
Very
And
good.
a number divisible by 2 ends with like multiples of 2, I guess.
Excellent. Excellent. Very well done. And what about 3? Do you know about 3?
I guess it ends with odd numbers.
Okay, so we'll talk about 3, we'll talk about 4, we'll talk about 6, all the different ones, because the basic ones you guys are already familiar with 2, 5, right? Let's talk about the different ones. Then 8 and 9. Okay, is this clear if we talk? Is this fine if we talk about these only? Because
Yes.
we have 5 other than
Yes.
this, so 5 is divisible. Any number which has 5 at the end or 0 at the end, it is divisible by 5. If we have two odd numbers, even numbers, you guys were right. Okay, let's talk about these first. Right. Um, okay. Now we have 3. Okay. For 3, the rule is okay. For 3, the rule is If,
Add all the number.
yes, okay. If the sum of digits is divisible by 3. Okay, for example, we have 81. For example, we have 21. For example, we have, let's say, 84 maybe. Okay. Now let's
63.
see. Yes. Okay. Very good. Now let's see. We have 81. Okay. So we need to do 8 plus 1. We get 9. Now we know that 9 is divisible by 3, right? 9 is divisible by 3. So this means that 81 would be divisible by 3. Is this thing clear? If the sum of digits is divisible by 3, we're talking about 81 here. 81 has 8 and 1. If 8 plus 1 gives us a number such that it is divisible by 3, it means that this 81 would also be divisible by 3. Yes, Samin, is this thing clear?
Yes, ma'am.
Okay, if we have 2, 1, how do we do it? 2 plus 1, we get 3. We know that 3 is obviously divisible by 3, so this would be. And if we talk about 84, we do 8 plus 4. What do we get? We get 12. 12 divided by 3, yes, it certainly is divisible. So 81, 21, 84. These three numbers are divisible by 3 because when we add their digits, we get a number which is divisible by 3. So is this thing clear? Certainly.
Yes, ma'am.
Yes.
Okay. Then for 4 we have if the last two digits are divisible by 4. Okay. So let's talk about examples. Then now for 4 they are saying if the last two digits are divisible by 4. Right. So what if we have 16 and what if we have 418? Then what if we have 228? Okay. You guys can double check this on your calculators as well. You certainly get the correct answer. Now we have 16. We need to check if 16 is divisible by 4 or not. By this, I mean that when I divide 16 by 4, I get 0 remainder. Okay. Remainder should be 0. This is what divisibility means. Okay. Are you guys clear with this concept?
Yes, ma'am.
Okay. Now we need to check for 16. So they are saying last two digits, 1 and 6. These are the last two digits. We know that 16 comes in the table of 4. So yes, this certainly is divisible by 4. But this rule is basically more useful in 3-digit numbers, right? Let's talk about 418. Sameen, can you please tell me if 418 would be divisible by 4 or not?
No, it is not because the last two digits are not divisible by 4.
All right. Okay. Very well done. So this would not be. And what about this number, Mikal? 228?
Yes, ma'am. It is divisible by 4 because 4 sevens are 20.
Excellent. Very well done. Okay. Perfect. Okay. Now let's talk about 6. If the number is divisible by both 2 and 3, you guys should note these points down because they are extremely important, and I'm telling you we are studying this because it is needed, okay, in the next contents. All right, so for 6 they are saying if the number is divisible by 2 and 3, then it would be divisible by 6 as well. For example, let's talk about 84. Okay. And let's talk about 216, and let's talk about 18. Okay. Now we have three examples. So who's going to tell me? Is 84 divisible by 2? Yes, it certainly is. Why? Because 4, the last digit, is an even number, right? So it is divisible by 2. So when we divide 84 by 2, we get 42. Okay. And is it divisible by 3? Yes, guys. We can check that through this rule. If the sum of digits is
Right.
divisible by 3, what is the sum of digits? 8 plus 4
12.
is 12. 12 is divisible by 3. So we know that this number would be divisible by 6 because it is divisible by 2 and 3. Sameen, is this clear?
Yes, ma'am.
Very good. Now who's going to tell me about 216?
Ma'am, 216 is also divisible by 6 because the
Mhm.
last number is even, so it means 2 is divisible.
Very
It is
good.
divisible by 2. And if
Excellent.
we add these all numbers, it is 9, so it is also divisible
Very
by
well
3.
done. Very well done. Okay. And yes, Sameen, what about 18?
It is also divisible by 6 because 2 nines are 18 and 3 6 are 18.
Excellent. Excellent. Very well done. Okay. Very good, guys. Okay. Now let's quickly talk about 8 and 9. If the last three digits are divisible by 8. Okay. Now this obviously is not that simple. For this, you will have to, the fact that you need to see last three digits itself would be a bit challenging, but you will not come across such questions. Okay. But let's do an example quickly. What if we have 1 to 8, and what if we have 2144. Okay, let's talk about these two examples. Right now, when we talk about 1 to 8, they are saying we need to check the last three digits. Okay, so obviously in 1 to 8 we only have these three digits, 1, 2 and 8, and they would be, it is divisible by 128. Like if you do 8 into 16, 8 into 6 is 8 and 4, and we get 128, right? So this would be because these last two digits are divisible. So yes. And what about this 2144? Who's going to check that and tell me?
Yes, ma'am, it is divisible. 8 18s are.
Excellent. 8 18s are 144. So this would be very well done. And are you clear, Sunny? Yes, Saneem, are you clear as well? Okay, she is not in the meeting. Right. Okay, so let's talk about the ninth one. If the sum of digits is divisible by 9, then it is divisible by 9. Okay, so let's talk about the examples. What if we have 81? What if we have 180? Yes, Amir?
Yes, ma'am.
So what about 81?
81 is also divisible because 8 plus 1 is 9. So 9 is
Very
divisible
well
by 9.
done.
9 ones are 9. And 180 is also divisible. 1 plus 8, 9.
Excellent. Very good. Okay. Perfect. So we are clear with this. Okay. Very well done. Now let's just clear this up. Any questions about it?
No, ma'am.
Okay. Right. So let's just clear this. Okay, Salim is back. Let's just wait for her. Let me ask her as well and then I'll clear this, okay? Right. So why have we discussed these divisibility rules, Amir? Because these would be used in prime
Okay, ma'am.
factorization. Before this, we did some basic examples like 12, 18, 36, but that was just to give you an idea, okay? After this, once we are done with these divisibility rules, we'll talk about some complicated numbers like 1240, some big numbers, and we will
Yes.
prime factorize those using these divisibility rules. Saneem, are you with us? Saneem, are you there? Can you please confirm? I can't hear you, but you are in the meeting. Yes, okay. All right. So let's talk about 1240, okay? Again, we are going to talk about prime factorization, particularly of 1240. And obviously, for such examples, we are not going to guess and do it that way, okay? We will make a table of this type and we will do it this way. So we need to prime factorize this number. Let's just write this number here, okay? And now think of the smallest prime number which would be divisible by 1240. Now, how will you think of that smallest prime number? Using the divisibility rules. What is the smallest
2,
prime
ma'am.
number? 2. Very good. Okay,
2.
2.
and since we have 0 here, so it would be divisible by 2. Okay. Now, when you divide
2, 6 are 12.
1240 by 2, you get
2,
620.
620.
Yes. Okay. Right. And yes, Saneem, which number is going to be divisible by 620, the smallest prime factor?
2.
Very good. Again, we have 2. And what are we going to get once we divide it?
310.
310.
Very good. Very well done. Okay. And again, it is 2 because we have 0 here. Again, when we divide it, we are going to get 155. Okay. Now, which prime factor are we going to consider? 2? Are we going to consider 2, 3 or
No,
5?
No.
ma'am.
5.
5. Okay. Very well done. Okay. Now we have 5. And finally, this would be 31. And yes, now which prime factor? 2, 3, 5. Which one?
31.
31 itself. Excellent. Because 31 is a prime number, right? So we get 1 and 1. Okay. Now when we write down the prime factorization of 1240, we will be multiplying all these numbers. You can double check that on your calculator as well, just for your reference, but it certainly is correct. So we can write down 1240 equals 2 into 2 into 2 into 5 into 31. Okay. So far we are on chapter 1. We have been discussing some contents yesterday, which was the first class. Today we are talking about prime factorization, and before this prime factorization, we have discussed the divisibility rules. Yes, guys, is this thing clear?
Yes, ma'am.
Yes.
Okay. Now you guys must be familiar with LCMs and HCFs, right? Like you must have been doing that.
Yes.
Yes.
And now we are going to do that using the prime factorization. Okay, so let's do that. Okay, let's start off with a basic example. Let's see, we are interested in finding out the LCM of 20 and 32. Okay, now for finding out the LCM and HCF both, The first step is to prime factorize these numbers. Okay, let's do that together. So we have 20 and we are interested in the prime factors of 20 and of 32. Yes. Okay, so let's do for 20 here. We'll have 2 because this is 0. The divisibility rule is telling us that the smallest prime factor would be 2. We'll have 10, again 2. We'll have 5, then 5, 1 and 1. So this would be 2 into 2 into 5. Yes? Is it correct?
Yes.
Okay, very well done.
Yes.
And if we talk about 32, so we can write 32 as, we need to check that we cannot do it directly. This is 32. Smallest prime factor is 2. So this would be 16. Yes. And then again we have 2. This would be 8. Again 2. This would be 4. Then again 2. This would be 2. And then finally 2, 1 and 1. So
2 cube into 2 square. 2 square.
very good. So let's just write down this way first. 2 into 2 into 2. How many 2s we have? 1, 2, 3, 4, 5. Okay.
5.
Okay. All right. Okay. Right. Okay. Now we are interested in finding the LCM. Okay. We were not just finding the prime factorizations. This is the end goal. Okay. Whenever you have been asked to find the LCM of two numbers, let's talk about the concept first. LCM is least common multiple. Okay, if you think of it this way, that you have table of 20, you have table of 32, and the LCM would be the number which is the smallest number coming common in both the table of 20 and 32. This is what the concept says. Okay, आपके पास 20 है और 32 है. 22 का एक table होगा. We will have 20, 40, 60 and so on. When we talk about 32, we will have 32, we will have 64, we'll have 96 and so on, right? इस तरह करते करते there would be a point जब हमारे पास दो numbers आएंगे जो कि same होंगे इन दोनों के टेबल में, उसको हम LCM कहते हैं, right? वो पहला नंबर जो दोनों टेबल्स में सेम आ रहा है वो LCM होता है, least common multiple. Okay, these are the multiples of 2, these are the multiples of 32. We need to find the common one and the smallest one. तो पहला least common जो दोनों में आ रहा है and multiple table के जो numbers हैं. Is the concept clear behind LCM?
Yes, ma'am.
Yes.
Okay, Rafe, are you there?
Yes, ma'am.
And are you understanding everything?
Yes.
Okay, please stop me there and then when you're not able to understand anything. Okay, please. You have to stop me. Okay, I don't mind answering students at all. Okay. So, okay, now we know the concept and everything, that's fine. But in exam, we need to know the method, okay? So we have to find the LCM of 20 and 32. These are the prime factorization. Now, what do? We need to write down the common ones. Okay, now let's just do it over here. Let's just find the LCM over here. So we are now finally working on the LCM. And how do we do it? For 20, we have 2 into 2 into 5. For 32, we have 2 into 2
5
into
2.
2. Yes, 2 to the 5. But I'm doing it this way just so things are clear, okay? I have to write down the
Yes.
common ones. This is common. And this
And
is
2
common.
is also.
Okay, right. And then what do I do next? I'll just
Like
write
we
down.
will like
Yes.
2 and 2.
I'll write down the common ones once only. And then the rest of the multiples would come as it is. Okay, so 2 and 2, these were common. Then we have 5. I've written 5 and then 2, 2 and 2. So 2 cube. So is this thing clear?
Yes, ma'am.
All right, very good. So finally we will have 2 to the 5 into 5. That would be 160. So 160 would be the number which would come in the table of 20 and 32 both. and so it would be the least common multiple. Right, guys?
Yes.
Yes, ma'am.
Okay, very good. Now, okay, we are done with this. Let's quickly rub the LCM and let's talk about the HCF now. Again, as I told you initially, when we talk about HCF or LCM, the method is almost the same. We will be using the prime factorization. So we are interested in finding out the HCF of 20 and 32. Before talking about the method, let's just talk about HCF. HCF is
Highest
highest
common multiple.
common factor. Okay, highest common factor. It's HCF. Okay. Now, what does it actually mean? It means that 20 is going to have some factors, 32 is going to have some factors, right? So we have to talk about the highest common factor. Okay, right. Let's do it this way first. We have 20, we have 32. Let's just write down the factors of 20. Can anyone help me with this? What are the factors of 20? 1, 2. Yes, guys.
4 to
4, 5,
5,
10,
20.
and 20.
20,
Very good. And when we talk about the factors of 32, we will have 1.
1, 2.
Yes.
2,
What about 3?
Uh,
Is 3 a factor of 32?
no, ma'am.
Why?
no,
Because when we add 3 into it's 5, so it's not a
Excellent.
multiple of 3.
Very good. Okay, and then which factor is going to come next?
4,
Yes. Okay, then 5 cannot be the factor. If we think of 6,
8,
okay, very good. 8, and then
32.
22,
32.
32. Okay, yes, right. And we are going to have the half of 32 as well. That is 16. Okay.
16.
Yes, very good. And again, when we look at the topic, highest common factor. What are the common factors? 2 is common, 4 is common, and these are the only two factors which are common, right? And then highest means 4. So 4 is the HCF of these two numbers. But again, in exam, you will not do it this way. I mean, it's your choice, but if they have asked you to do it by first writing down the prime factorization, let's do it that way, okay? Is it clear?
yes,
Okay.
Yes, ma'am.
All right. So let's do it quickly. I'll take 10 minutes extra because we started the class late. I hope that's okay with you.
yes,
Okay. So for 20, we have 2 into 2 into 5. For 32, we have 2 into 2 into 2 into 2 into 2. Okay. When we talk about HCF, we just have to find out the common ones. This is common and this is common. And we just write down the common ones. So 2 was common, and then this 2 is also common into 2. This is 4. Okay. So this way or the other, you will obviously get the correct answer. You'll obviously get the same answer. But this is how you do using prime factorization. So I repeat, in HCF, you just write down the common ones. In LCM, you also write down those which are not coming common, right? Is the difference clear?
Yes, ma'am. Excuse, ma'am.
yes,
Yes.
yes.
मैम जब हम एलसीएम लेंगे 20 एंड 32 का तो इसमें होगा 2 स्क्वायर 2 स्क्वायर
Very
2
good.
into 2
Mm-hmm.
into 5 into 2 cube.
Excellent. Yes, yes. This is the HCF, and the LCM would have been, which we just did. The common ones will come once only, 2 into 2, just like the HCF. So this basically is the HCF multiplied by all the numbers which were coming once only, okay? So this would be the LCM and this is the HCM. Any more
Okay.
questions?
So in LCM, we have to
Yes.
multiply these numbers or not?
In LCM, yes, we have to multiply all those numbers which were not common, right? 5 is not common,
Okay.
we are writing 5. 2, 2 and 2, these 3 2s were not common, we are writing those, and we are writing the common ones once only. Okay?
Yes, ma'am.
Okay. So
Like,
I'll
like this is the answer, or we have to solve this further?
Oh, all right. You're asking about that. Yes, I solved this and we got 160. Yes, you have to solve it. Okay, I'll tell you.
Okay.
It could be, it totally depends on the question. Okay. When we will do past papers, you will see the question could be that they're saying write it down, write the LCM as a product of prime factors. So this is what it is. But if they have just mentioned to write down the LCM, you have to solve it. Okay. How are we going to solve it? 2 into 2 is 4. 2 into 2 is 4. 4 into 5
Yes.
into 8. This would be 20 into 8 and then that would be 160. Right? Yes, you have to solve it. So are you clear now?
Yes, ma'am.
Okay, sure, 100%.
Yes.
Okay, so, right. So, okay. Finally, we are on the last topic, that is number sequences. We have to discuss this. Number sequences. Okay, so this is the topic which we'll talk about right now. Okay, so okay.
Yeah.
Manu, your mic is on. Okay, right. So we have to discuss number sequences, and we have 1, 3, 5, 7. Okay. Now the very first question is that what is a sequence? In a sequence, we have some numbers which are going on like this. And in these questions, you will be asked to find the nth term or 50th term or 20th term. Okay, either they'll say nth term. When they'll say nth term, this means that you need to find out in general. And when they specify it, you have to find out that value. Okay, now my question is, what if I ask you to tell me the 10th term? Are you going to first understand the sequence and then go on continuous till 10th term, or we'll use a formula for that?
A formula would be easy.
Very good, excellent. Okay, so the first thing is we have to understand the sequence. So we have 1, 3, 5, 7. So it looks like that either the pattern has odd numbers or we are adding 2 to the previous term, right? It could be either way. We have all the odd numbers in the sequence, or we are adding 2 to the previous number. We are going from 1 to 3, we are adding 2. We are going from 3 to 5, we're adding 2. From 5 to 7, again, we're adding 2, right? So is this example clear?
Yes.
Okay, this was a
Yes,
very
ma'am.
basic example. Let's talk about another example. What if we have 1, 3, 9, and 27? What if we have this? What is going to happen in this case? What do you guys think? So here we are adding 2, but here we are adding
3.
6. And here, like, it is
6.
not that straightforward. So it would be different. So yes, guys, any idea? Yes, we are basically
Yes, ma'am.
multiplying with 3.
Like,
Yes, right, Amir?
yes.
We are multiplying the previous term with 3 to get the next term. 1 into 3 is 3. 3 into 3 is 9. 9 into 3 is 27. Okay, so this, in this sequence we were adding two terms, in this sequence we are multiplying a number to get the next number, and we are having different sequences. Okay, now what if we talk about another sequence? Let's say this one. Here we have 1, 3, 7, 15, and 31. What do you guys think? So this was about adding, this was about multiplying, and yes, we can have any type of sequence, okay? So we are not adding a number, like if we are adding 2, then what about this? Like if we say we are adding 2, then from 3 to 7 we are adding 4. No, it's not the adding sequence. We'll talk about the terms later, okay? We'll talk about arithmetic sequence and all that later. At the moment, you have to understand the content and not the terms, okay? So do you think that we have multiplied something? Let's say we have multiplied 3. Then what about 3 into 7? Have we still multiplied 3? No, it's not like that. So it must be something different. And what is that different thing? We are multiplying the previous term by 2 and then adding 1. How? So 1 into 2 is 2, and then 2 plus 1 is 3. Again, 3 into 2 plus 1 is giving us 7. Are you guys understanding this?
Yes.
Yes, ma'am.
Are you sure? Okay, how are we getting this 15 from 7? Who's going to tell me?
Ma'am, we are multiplying it by 2 and then adding 1.
Very good. Okay, so you guys are clear. We can either have simple addition, subtraction, multiplication, or both, right? Okay. Now, we have a question. Find the nth term and hence the 50th term of the sequence 4, 7, 10, 13, 16, and 19. Yes, how are we going to do this? Okay, so for such questions, first we need to identify the pattern, okay? Let's make a table quickly. This is n and these are the values of sequence. So this is for n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, and n equals 6, okay? By n equals 1, I mean the first term is 4, n equals 2 means the second term is 7, okay? Nth term. So n is the number of term, okay? If we are on this, it means the third term is 10. Okay, now let's just understand it. So from 4 to 7, we are adding 3. From 7 to 10, again we are adding 3. From 10 to 13, again we are adding 3. So this is clear that for every next term we are adding 3, okay? But how are we getting this first term? Yes? Any idea?
By adding 3 to 1.
Okay, all right. That is close. Okay, so you are saying that we are doing for n equals 1, we are doing 3 plus 1, that is 4. Okay, let's see. What if I say for n equals 2? For n equals 2, we have 7. So are we like adding 3 plus 2? That would be 5. And we have 7. So it looks like we have to do this way. We need to do this way. This is going to give us 7. And what if we talk about n equals 3? We have 10. So 3 into 3 plus 1 is 10. Okay. So what do you guys see? We can clearly see for n equals 1, we have 3 into 1 plus 1. Okay. Focus on this 1. For n equals 2, we have 3 into 2 plus 1. So focus on this 2. And for n equals 3, we have 3 into 3 plus 1. Focus on this 3. So whatever the n value is, it is coming over here, okay? So this way, we can see that for the nth term, it would be 3n plus 1. This would be the nth term, right? For the second term, we have 3 into 2 plus 1. For the third term, we have 3 into 3 plus 1. So for the nth term, we will have 3 into n plus 1. Is this clear?
Yes, ma'am.
Are you sure?
Yes.
Okay, very good. So when we have nth term, we can easily find the 50th term. How? If the nth term is 3n plus 1, the 50th term would be 3 into 50 plus 1. That would be 3 into 5 is 15. We have 0. That would be 150 plus 1. So 151 would be the answer, right? So is this thing clear?
Yes, ma'am.
Okay. All right. So any questions? Any questions? Anything which you guys would like to ask?
No.
Okay. So only a small thing is left. We'll do that tomorrow. So far, we are done with today's lecture. So if there are no questions, I'll stop